Okay, I guess we are ready to get started, and we should switch the language because this was announced to be an English session, so I'm going to talk English in the next 60 minutes. Welcome to my session about Azure Container Registry, a managed serverless Docker container registry. Wow, that are a lot of buzzwords in a single title, okay? But don't worry, this will not be a marketing heavy presentation. We will see a lot of demonstrations, but yeah, let's get started. My name is Stropek. I'm an Azure MVP for many years now, and I'm an Azure Regional Director. That does not mean that I am an employee of Microsoft or something like this. That does just mean that I'm doing a lot of work on the Microsoft platform. In my own company, the company Software Architects, we have been building cloud-based solutions for 10 years now. We started with Azure in the very first technical previews, and ever since we have been building solutions that we run and market ourselves, and we help small, medium, and large companies to create architectures to go into the cloud, and our overall topic is always software as a service. This is what we do, and this is what I have been doing in the last 10 years. If you have any questions concerning the topic, please don't hesitate to link your account with mine on Xing, LinkedIn, Facebook, Twitter, whatever social media platform that you're on, or just shoot me an email. I'm more than happy to answer your questions. By the way, this session is going to be recorded, so you will have the possibility to watch this session or rewatch this session if I'm too fast, or if you want to recap the demos that I'm going to show, just take a look at the video. What will be the agenda? We will do a very short introduction and overview based on a bunch of slides. These slides, I've primarily created them for you in order that you have, let's say, a kind of notes area that you can take with you home and recap what I have told you. But the largest part of my presentation will be demos. So I will show you a lot of things that Azure Container Registry is able to do, and we will do that live. And if the demo gods are smiling, if the internet works, and if the cloud doesn't break, then I will be showing you a lot of demos. You can get the slides. They are already on speaker deck, and let me unveil the last one, and you can also get the samples here. So if you want to take a quick photo from this slide, if you think that you will need this material immediately and you do not want to wait until they are sent to you by email, take a photo from this slide. I have created 2 bit.ly links for you where you can immediately download the slides and take a look at the sample script. Of course, everything is on GitHub, and everything that I show you here is MIT licensed. It's open source. Take it, reuse it, redeliver it, send it to other people. I don't care. Do whatever you want with it. I hope it's useful. Okay, so now let's go into the topic. Let's start with some basics. What is this Azure Container Registry? Azure Container Registry is a storage platform for Docker-compatible container images. It supports Windows and Linux, so you can store your Windows images and your Linux images. And in total, you have a 5 terabyte storage limit. That's currently the upper storage limit. Of course, that might change in the near future. It is also possible to store Helm charts on Azure Container Registry. And another important one, when we talk about clouds, data security is always a very important topic. All your data is encrypted at rest and is just decrypted ad hoc, just in time, whenever you access the data in your Azure Container Registry. And now comes the important part. The Azure Container Registry is a fully managed serverless service. That means you do not create VMs, you do not install any software, you do not patch anything. It's fully managed by Microsoft. You just pay for what you really use. You upload a bunch of images, you have a little bit of storage in your Azure Container Registry, and you pay for what you really use. You can also, you will see that in the demo later on, you can build your Azure images in the cloud, and you will pay by CPU millisecond. So it's just like electricity coming out of the socket. You don't care about servers, you don't care about sizing or auto scaling or things like that. It's just managed. Microsoft did not create their own container registry software or whatever and do copyrights and IP on it. No, it's just the open source Docker Registry 2.0. The benefit, the product here is not the software, because Microsoft is contributing to the open source code that is available on GitHub. The product from Microsoft is the managed offering here. Okay, so this is a very important thing. This is not a new creation. The things you will know and love from your container registry today from Docker, you will find all these features in Azure Container Registry, because it's just the container registry that you're used to. That's a very important point. That also means that you can take your Docker CLI to interact with this Azure Container Registry. Push, pull, and all the things that you are used to, you can do it with the Azure Container Registry. An important one, especially in enterprise context, is that the Azure Container Registry is integrated with Azure Active Directory. So if it happens that you have Office 365, for instance, then you have already an Azure Active Directory. This Azure Active Directory might be connected with your on-premise Active Directory. That means single sign-on for your developers, for instance. And that also means that you can protect access, read or write access to your images based on service principles stored in your Active Directory. And that's, especially in enterprise environments, a very important thing. There is an additional administrative account that is created or can be created. It's just for development and debugging purposes. Typically, you don't use that account for production workload. I will show you in my demos working with Active Directory with my own individual ID, and I will show you demos using service principles in the background. If you want to read more, just follow the link and you will see all the details about the security model here. Next one. The repositories are structured in a multi-level namespace way. Let me show you. Here we see a typical multi-level namespace. You see my registry, that's the name of the registry. You can have as many registries as you want. That's just up to you. Create as many registries as you want. You don't pay for the registries. You pay for the storage and the CPU that you use in ACR. You can use a multi-level namespace system here, and here you see the repository, and here you see the tag, so you can store multiple images based on tags in your repository. That's it. Content trust, and I mean signed images, is also supported, but this feature is currently in preview. I have added the link here. I will not do a demo about content trust here in this 60 minutes. It's just a matter of time. But I wanted to tell you that this is supported. So if you have an environment that is not fully trusted, maybe you exchange images with your partners or your suppliers or customers or whatever, then you can use the possibility to sign images, and the recipient of the image can check whether the signature is okay, whether the image was really published by you and nobody else. A very important one today in larger application scenarios, speaking of microservices and things like that, is the support for webhooks and in general hooks, service hooks based on messaging platforms and so on. Because maybe you want to automatically build an image whenever you check in something in GitHub. And when this build has been done, another build should be triggered. And when all these builds have finished, you want to trigger maybe a deployment to a managed Kubernetes cluster in Azure or anywhere else. Maybe you want to send out some emails to people who need to do some manual testing and things like that. So webhook support and in general event grid support, event grid is a messaging platform on Azure, is built in, and I'm going to show you a demo about that. Yes, and I meant process integration here. Good. Registries. These are those registries, and you can create, as I told you, as many registries as you want. The important thing is that, of course, you should create your registries where your deployments are. So if it happens that you use Azure or other cloud platforms distributed across the globe, you have some maybe web apps that you deploy to Asia, to North America, to Europe, and so on, then you should create different registries in different regions. There are 3 SKUs available. Here are the SKUs, basic, standard, and premium. I will not read the docs for you. You can just check out the features and the pricing here. especially the premium is important when it comes to regional dependencies, because the premium version supports geo-replication out of the box. So you publish your image to, for instance, Europe, and Microsoft will care for distributing your images across the globe into all your Azure regions that you want your images to be. So you do not need to manually publish your images all across the globe. That's done in the Microsoft network, and that means you don't pay for the network and things like that. And it's pretty fast to distribute images all across the globe using this replication feature. By the way, I am sure some of you wonder, what's the price? Can I afford that? Let me show you the pricings here. The price per day in the basic version is 0.1 euro, 0.5 euro in the standard edition. The included storage, you can read the numbers yourselves. You can have 2 or 10 webhooks. Geo-replication is only available in the premium version. Of course, you can buy more storage. Price per gigabyte is 0.003 euro per day. And you can use container build in the cloud. I will not count the zeros for you. Please do the maths on your own. If you want to run your container builds, you can immediately calculate exactly what you're going to pay for it. That's no ops. That's not DevOps. That's no ops. You cannot manage the servers on your own. You don't scale anything. Just put your images in the cloud or run your workload and pay for what you really use. That's serverless at its best. By the way, you don't need to run anything else in Azure. So if you want to use that just as your container registry and you want to run your containers in your on-premise Kubernetes, or you run Kubernetes on any other cloud or hosting platform, hey, feel free. You can, of course, use ACR. However, ACR is really nicely integrated into all the other Azure products. Well, kind of obvious, isn't it? Repositories. Yeah, I told you repositories are inside of the registry. You can upload as many repositories as you want, and you can tag them. So you can store multiple versions of an image. Here you see some examples of an hierarchical namespace. This is the registry. This is the namespace. Here you see a 2-level namespace. This is the repository. Oh, sorry. This is the repository, and this is the tag. Here you see the tags. ACR tasks. ACR tasks are another great feature of ACR. That means you can take your Docker files and all your sources and just replace your Docker build command with an ACR build command. And if the rest is nearly the same. You just say ACR build, and that means you do not need a Docker daemon to build your Docker images. It just takes the Docker file and all your sources as you are used to from Docker build. Then it uploads it to ACR. Then in Azure ACR, this stuff is built. You pay per CPU second. You have seen the prices. And then the result is automatically pushed into your ACR. So you do not need to upload any large images or whatever. You just upload your sources and the rest happens inside of ACR. You can use that in 3 different ways. You can use that either on demand. You create a task, you upload your Docker file and your sources, and the task runs and you have your image. That's nice for smaller workloads, for development scenarios. But in production, it should look differently. In production, you can trigger check-ins based on GitHub check-ins. Sorry, your builds based on GitHub check-ins. Whenever you check in code in a GitHub repository, your ACR build will be triggered automatically, and the resulting image will be written to your ACR, your registry. Or the third one is especially interesting in enterprise scenarios. You can also automatically trigger the ACR build whenever the base image changes. Imagine that you are depending on a base image on a Linux distribution or any platform like Node or whatever. And if the base image changes, ACR will recognize that automatically. It will automatically trigger the build of all dependent images and so on and so on. And it will push the new images into your registry. Then it will send you a webhook, and you can, for instance, then take the webhook and deploy your application into your Kubernetes cluster if you want. And then you have a nice integrated way of working without you having to do anything. All is done by Azure Container Registry. This triggering of base images works for base images that are stored in ACR, but it works for any base image that lives in a public registry. So if the base image in the Docker Hub changes, it can refresh your dependent images too. Both things work, GitHub and base image refresh at the same time. No, GitHub supports webhooks, has supported webhook for quite a long time, so Microsoft would not have would not have been necessary to buy GitHub just to integrate into webhooks. That could be built by anybody because GitHub webhooks are just there. I will show you the demo in a second, so you will see it. I have, I don't know, 2 more minutes with theory, and then we go into demos, just as promised. The last one, that's very important, the multi-step task. In the multi-step task, you have a WAML-based, so a text-based format with which you can create a series of dependent build, publish, and execute tasks. So if you have a more complex scenario where you say, build this image, then build this image, then build a test image, then please run the unit tests inside of this image. If this is correct, then build a 4th image, then push all these things into a registry, and at the end execute. I think you get the point. You can describe such workflows in WAML files, yet another markup language, JSON without the curly braces. Check it in, and then ACR will execute these complex multitask flows for you. So it's a kind of build, publish, and execute engine for complex microservice architectures where you just pay for the CPU that the building really takes. That's the whole idea of this possibility here. This is currently also in preview, as you see, so you can try it, but officially it's not supported for production workloads. However, you can try it. If it works, nice, you always have a fallback. So I don't think that this is really critical. Officially, it's currently in preview. Any questions concerning the theoretical overview of what ACR is capable of doing? No? Nice. Then I will now sit down and we will do a lot of demos. I have a summary slide, but you will not see any slides anymore. So, what I have created for you is a nice little environment. Here is my Azure environment, and as you can see, I will zoom in a little bit. I have just created a logic app, which is a workflow. We will use this workflow in a second. I've created a small web application which displays some information about my container registry. It's not necessary. It has nothing to do with ACR, and I have a connection to my Slack system. I will show you that later on. We will do some nice interactive workflows where we get a Slack message whenever somebody pushes an image into our registry. This is what I have prepared, but I have no Azure Container Registry yet. We will create that from scratch, and we will take a look at all the features that I have just talked about. My environment here is Visual Studio Code. It's a lightweight editor. Maybe you know Visual Studio Code already. It's available on Windows, Linux, and Mac. It's 100% free. It's open source, and you can use it on your own. And the last thing that I would like to emphasize here, I'm using a plugin in Visual Studio Code. This plugin is called Azure Cli Tools. The Azure Cli Tools give me a possibility to write a CLI script here on the right-hand side and to execute it immediately. So this is my script, as you can see it here, and whenever I execute the statement here, it gets executed down there in the terminal, and this is just Bash, Ubuntu Bash, running on top of my Windows machine. So I'm using Linux on top of Windows, but my whole execution environment here is Linux. So I'm not bound to Windows. I've chosen Linux because I like programming with Bash in Linux. Okay, I've prepared a bunch of things. I've set up a bunch of variables, which are just names for resources. Don't worry about them. You don't need them. You can take a look at them in my GitHub repository. I have logged in, so I'm already authenticated with my Azure subscription, and I have selected the right subscription, so I'm really inside of this Azure account here. Nothing special. Additionally, I have created a resource group. I will show you that here. A resource group is a kind of logical grouping in Azure. If you are not that familiar with Azure, your Azure subscription can be divided into logical, let's say, sub-data centers. And these are called resource groups. And you add Azure resources always to a resource group. It's a kind of container. You can define access policies in the resource group. So some administrators might have read access, some might have write access. That's the purpose of a resource group. And I've created a resource group for this demo. This is already done, so we don't waste time because this has nothing to do with ACR. And now comes the interesting part. The first thing that I would like to do is I would like to create an Azure Container Registry. By the way, of course, I can do that interactively. So I can click on plus, Azure Container Registry, and hit enter, and I will see the Container Registry exactly here, and I can click on it and I can create, and I have a nice little UI with which I can create the Container Registry. But hey, we are here in a DevOps conference. So what we want to do is we want to automate. So therefore, I will not touch the portal. I will write everything inside of scripts. But of course, you can do every single step that I do here also in a nice UI. But typically, Microsoft is known for using a lot of UIs in their demos, not being good in scripting. I wanted to show you that that's not true anymore. So yeah. By the way, you don't need Visual Studio Code. In Azure, you can also click here, this little button here that gives you the Cloud Shell. And if you click on here, you directly get inside of the browser. You also get a Bash environment, or if you prefer, you can also get a PowerShell environment. And then you can start hacking directly here in the browser, or make that full screen if you want to do that like that. I will not use the browser-based integration. I will use Visual Studio Code because then I have nice Git integration and things like that. So let's create the Azure Container Registry. Let me run this statement, and while this statement runs, I can show you what this statement does. It says AZ, which is the command line interface of Azure, ACR, Azure Container Registry, create an Azure Container Registry, put it in the right resource group, give it a certain name, use a certain SKU, basic, standard, or premium, and give me an admin for debugging purposes. This is what I'm essentially saying. Okay? And down there, you already see that if I zoom in a little bit, I got some nice JSON response that tells me a little bit about the created Azure Container Registry. That's all I need to do. Now, if I click on refresh, I have my, here it is, Azure Container Registry, and that's the nice thing of serverless. I love that. We're done. This is a production level, production ready registry. It's done. It's auto-scaling. We can immediately start working. It's secure. We don't need to do anything else. This is why I personally love Platform as a Service and serverless, because setting this up on-premise, but with thinking about the whole infrastructure and the high availability takes a lot of time, and here I get a lot of productivity. I understand that some people need on-premise software, but for many, many projects, this is perfectly fine. So, this was creating the ACR. Now, what I can do is I can get the ACR identifier. Let me quickly show you what I mean with that. Echo ACR ID. As you can see here, I will not go into the very much details here. Every resource in Azure, every piece of platform as a service, infrastructure as a service, every asset that you create in Azure gets an ID. And this is the ID of my Azure Container Registry. Of course, you don't remember that. I've written it into a variable, so from now on, I will refer to this variable. But internally, this is the kind of addressing that Azure uses to address any resource that is created in their cloud. So now we have the Azure Container Registry ID in this variable. Okay. Now I want to work with this Azure Container Registry. If I want to access this Azure Container Registry with my Docker, CLI, or things like that, I have to somehow authenticate with the ACR. And I have three possibilities. Let me show you the one that I'm not going to use because it's not recommended for production use. If I go here, access key, you can, if you want, ask for an admin user. You see that here. But you can also disable the admin user. If you create an admin user, you will get a user plus 2 passwords that you can easily roll over if you want. And this user can immediately be used to authenticate using the Docker login statement. Okay? Docker login, blah, 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 this user, this password works. You don't need to create a service principal, things like that. It just works. Again, this is not for production workloads. This is if you are learning, if you are debugging, if you are developing, and if you don't store any critical images on this ACR. Now let's talk about the things that are recommended for production use. The first thing, I'm not going to do that, but I will tell you about it, is this ACR login statement. This ACR login, as you can see, just takes the registry name as a parameter, but it doesn't get a user and a password. You know what this does? This uses my identity as the developer to access ACR. Okay? So this is for the developers who would like to push or pull images to or from the registry. And how did I authenticate on my machine? Using my Azure Active Directory user account with multi-factor authentication, single sign-on with your enterprise, and so on. So the first takeaway here, your developers don't need any kind of password here. What they need is an Azure Active Directory account with possibly multi-factor authentication, and that's it. And then they access the ACR interactively using their individual Azure Active Directory or your Active Directory account. That's the first one. That's fine if you are a developer and I can run it. It doesn't make any difference. It takes a few moments and then we are done. Yep, this is good. Yes, I didn't install a Docker authentication helper because this is just a demo environment. So this warning could be removed if I configure a Docker authentication helper. But at the end of the day, now my Docker CLI knows how to interact with my container registry. That's the one. But if we are talking about services in the background, think for instance, you want to automate builds and so on, then you don't have an interactive user who is active, who can interact with the Azure Container Registry. In that case, the Azure Container Registry supports creating so-called service principals, application accounts if you want. Okay? You can create as many service principals as you want in Azure Active Directory. And these service principals use either a client ID and secret, or they can also use client ID and client certificates if you want. It depends on your specific needs. There is also a technology in Azure which is called managed identity. In this case, Azure manages the keys, the secrets and the rollover and so on, everything automatically. You could also integrate managed identity with ACR. It's not that trivial, but it is possible already, and it's getting better. But currently, we are just creating a user. You see, here I'm creating a service principal, Azure Active Directory service principal, create for resource-based access control. RBAC stands for resource-based access control. That means I'm creating a service principal with which a machine, a service, can access the container registry. Let's create the guy. Yeah, already exists. I have created this user before, so this is perfectly fine. Let's get the user. Again, I need the ID. I've talked about IDs already. This is just the internal ID of the service principal. Nice. Very good. So now we need to allow the service principal access to the container registry, because some service principals might need to push images, and some other service principals of another application, think Kubernetes for instance, might only need to pull images. So I will not give my Kubernetes cluster contributor access to my container registry. It just needs read access to my container registry because it just pulls out the images. Only the applications or scripts or automation scripts that really create images, my build server for instance, they need a service principal that has contributor permissions. So now I'm creating for this first sample a role assignment, you see it here, that gives me contributor permissions. Let's do that. Azure role assignment create, service principal ID, contributor role, ACR. Very nice. And now I can start working, because now if I zoom in here a little bit, I can use the good old friend Docker CLI to talk to my ACR. I don't need any kind of Azure specific software. This is the proof that we are just talking about a a regular registry just like Docker, because now I'm using the Docker CLI to log in. Let's try that. And here we are. As you can see, the service principal that we have created has now successfully logged in into ACR using the Docker CLI on Linux. So imagine that this would now be your build server, the build server that is building the images, and this build server wants to, at the end of the build process, push your images into the ACR. It could use exactly that process, and you could give it a service principal, and with that, the build server, it has no idea about Azure, it just uses Docker, can now talk to the ACR. Is this approximately okay? So we had 3 possibilities: individual ID for developers, the admin account just for debugging and developing purposes, and the service principals backed by Azure Active Directory, and this is what we have used here. Nice. If you have any questions, please don't hesitate to interrupt me. So, now let's push something into our container registry. I thought we could just take an Nginx web server, Nginx Alpine, give it the right tag. In this case, I'm just tagging it. Oh, I have to talk about that one. The registry always has the URL, your registry name, .azurecr, like containerregistry.io. This is the name that Azure has chosen for their container registry. So whatever registry you create, it's always called your registry name.azurecr.io. And if you would like to push a Docker image that you have, in my case on my local computer, and you would like to push it into your container registry, you just give it a tag. In this case, $reg, I think I called it DevOps Munich 18, something like this. I tag it with DevOps Munich 18.azurecr.io, and then I can push it. Let's give it a try. Okay, Docker tag ran, and then we will run the Docker push statement. And if we're, yep, looks good. And you see now we are pushing. And please note that I just used the regular Docker push statement. It's nothing special. It's not an Azure something tool to push something. No, it's just the regular Docker push. You can do it on Windows, Linux, and Mac just as you're used to. And now if I go into here and I take a look at the repositories, here we have our Nginx repository, which we just pushed from my local computer into the Azure Container Registry in the cloud. Okay? And if we would have a premium SKU, and if the premium SKU would have replication, I have a premium SKU, it's really trivial to replicate your images all across the globe. I can just pick a data center, and all I need to do is I hit create, and that's it. I will not do it here now because I have to pay for that. But that's it. Now that's how you install a replication. That's it. Just click on a on a world map, and you are done. Okay, nice. So we have pushed the first thing into our registry. What if we do not want to use a ready-made image like Nginx, for instance? I mean, Nginx will just say, welcome to Nginx. It's nothing useful. Imagine you have created your own web application. And I have created the world's most greatest web application on earth, Hello World. It consists just of an index.html, but please use your imagination, okay? This could be your PHP, Java, .NET Core, Angular, React, whatever application or microservices or whatever. And I have created a super complex Docker file, which consists of a label and a single copy statement. And again, it's using Nginx as a base image. That's all I use. So we have our own Docker image here, which is a nice single page web app consisting of a hello world index.html. But the concept is the same. I hope you forgive me using a very simple sample, but I like simple samples for demos because it helps me bringing across the point, and we are not distracted by complex frameworks or things like that. Of course, I could build this thing locally. I could run Docker build, but this requires that I have a Docker daemon available on my network. Imagine that I don't have a Docker daemon, or I don't have the CPU capacity to build all the things. I don't want to wait. I would like to offload the build to Azure. And this is what we do then. Instead of writing Docker build, I'm just writing AZACR build. I'm telling it what the name of the image should be, and I'm telling it where it can find the Docker file in the local directory. All the things that you know and love, like Docker ignore and so on, they work. They work as expected. So let's quickly run this guy. Clear and here and give it a try. So now, if everything works out smoothly and the internet works, it will transfer my files from my local computer into Azure. Did I execute? I executed the wrong line. I'm very sorry. Now I executed the correct line. You see? And now it's waiting for an agent. So now it's provisioning a Docker host, a Docker daemon for us in the cloud ad hoc. It already updated. Let me zoom in a little bit. It already uploaded my sources, which it needs to execute the Docker build statement in the cloud to the cloud. And now it gets the Nginx image, the Nginx library image from the public repository, because we have a from Nginx Alpine statement. It recognized that it already exists, of course, because we have already pushed Nginx Alpine to our cloud. And now it's running the usual build statement. You see, it's already built. It executed the copy statement. And finally, in a few seconds, we should be done. Here you can see it. It's already pushing our newly created image to our Docker Munich 18 ACR IO hello world web. V1 is the tag, and now we are done. And if I go here, go into my container registry and take a look at the repositories here, you will see that I now have a new repository, hello world web. And this thing has now been built in Azure. And this is how you use the serverless build functionality of ACR. And as I told you, you do not need to provision any kind of build servers or Kubernetes clusters or VMs or something like this. You just pay a very small amount of money per CPU second. And if you don't build something, you don't pay anything. If you build a lot, you pay more. Question? Yes. Yeah, they are. Like in all cloud systems, network is built separately. If I remember it correctly, ingress data, so data coming into Azure, is free, but data that you take out is to pay. That's the idea. Typically, network is never an issue. So the networking costs are very, very small. If you don't want to start a new Netflix where you store and stream a lot of data over the public internet, then typically network is not an issue. I've done a lot of Azure projects and network nearly never was an issue. Yeah, you can take a look at it. It's really, really cheap. And by the way, we are talking about Docker here. So what we are uploading is just our sources. Yep. I will show you the answer because it is important. Azure pricing, network, bandwidth, and here it is. Inbound transfer, that means data going into Azure. If you download something from the internet, it's free. If you upload something to the internet, the first gigabyte per month are free, and 5 gigabyte to 10 terabytes are 0.074 euro per gigabyte. Does this answer your question? Okay. Nice. So, next step. We are good in time. Imagine that you would like to know, hey, how much do I have in my Azure ACR? What will be the cost at the end of the month? Then you can run this. You can run the statement Azure ACR show usage. It will tell you the usage in bytes, as you can see it here, and it will tell you how many of your webhooks you have already used. In my case, I have no webhooks, and I have used, well, you can count the bytes on your own. And on the left-hand side, you see the 5 terabyte limit that I was already mentioning. So this is how you can take a look. Nice. Now I have a nice little image in my Azure ACR, and I would like to run it. Of course. There are multiple possibilities how you can run an image from the Azure Container Registry. In Azure, you can use serverless and platform-as-a-service offerings. Serverless meaning Azure Container instances, platform-as-a-service meaning managed Kubernetes. That means Kubernetes managed by Microsoft, but the regular Kubernetes, or Azure App Services. My point is not so much showing you how to run a container in Azure, because you can run the container anywhere. But I would like this example to show you again another important feature when it comes to using production workloads and production-ready security in your Azure data center or other cloud. Because our problem is that we need to somehow safely store the service principal and the service principal's password in order to not have it somewhere laying around on a developer workstation, or have it written into a, I don't know, config file that happens to be checked into GitHub. And I think you all know what I mean. This is definitely not the thing that I would like to do. For that, Azure has a service which is very, very useful, and it's called Key Vault. Key Vault is a password manager, not for humans, but a password manager for machines. And what you should do shows this example. You should write your ACR service principal names and secrets into Key Vault, and whenever you interact with your Azure ACR, you should always get the newest secret from Key Vault. And Key Vault is audited. It fulfills a huge number of ISO whatever certificates for security. It is really secure. It is backed by hardware security modules and a lot of other things. Just Google for Key Vault and you will see the details here. Let me show you how I create a Key Vault. It's very simple. It's just a single line of code. Azure Key Vault create and give it a name. Should be done in a second. Okay. Let me see. Key Vault is already in use. Okay, I need to. See it. I have a copy and paste. Where is it? Here we are. Copy and paste mistake here, because the Key Vault, here it is, Vault image. I have a typo here. It's called IMG here. I'm sorry. Okay, so now it should look better. So let's recreate the Key Vault. Running. Very good. So now it's creating a Key Vault. If I go here back to my resource group and refresh this guy, you will now see here the Key Vault. Of course, again, we could interactively go into this Key Vault and create certificates or keys or secrets. We can manually import secrets or generate ones. We can set an expiration date and activation date, and all these things, they work really nicely in Key Vault. But for us, now Key Vault is done, we would like to store the service principal in Key Vault. And I think this is a very nice example of how you should automate your processes in Azure. As you can see it here, I have created another Azure Active Directory Service Principal create statement. And this time, I only create a reader because the Azure Container instances or Kubernetes or whatever I'm running does not need to publish images. So I'm creating a reader. And I let Azure create the secret, and I never display the secret. I don't want to see it. I use it immediately as the input to my newly created Key Vault. Okay? So I let Azure create a secret and write it directly into this hardware security module backed key management system, whatever. Okay, let's do that. Let's run it. Okay. I created, okay, let me quickly delete this guy again, because I have tried this demo before I went on stage and I have forgotten to delete this service principal. I will now delete it and recreate it so you really see that this works. Okay, now let's rerun it. Yes. Now it creates the user, the service principal, creates the secret and writes the secret into my key vault. It will be done in a few seconds. In the key vault here, if you go to secrets, here is secrets. The secret will be shown in a second. Any questions so far? It will take 10 seconds. And yeah, now we are done. Let me show you that. Here, you see the password. We have never seen the password. It's now written in my key vault. And let's add the username too. Not only the password, but let's add the username. So we have username and password written in key vault. Here it is. But we don't want to work with the portal. And now we are good, because now we can run the container from our Azure Container Registry. So we pull down the image that we have created before and run it in a serverless way. Azure gives you the possibility to run as many containers as you want on a pay-as-you-go basis with a service which is called Azure Container Instances. Azure Container Instances frees you from being necessary to run your own Docker, daemon, or Kubernetes cluster or whatever. It's a very simple way to run containers. It's a kind of, let's say, scale-out version. You just say, give me a container instance, and if it runs for 30 seconds, you pay for 30 seconds. If it runs for a week, you pay for a week. That's the idea behind Azure Container Instances. It's not for the long-running web apps. You typically use Kubernetes or app services for that. It's for the workload that is only running for short or medium terms. And in this case, let me emphasize that one. I will give Azure Container Instances my service principal, but again, I will never download the password. I will give the password directly from Key Vault into Azure Container Instances, so it will Azure Container Instances, so it can have only read access to my Azure Container Registry. Let's try that. Yep, question?
Does that mean it will never get sent over the network?
No, that does not. No. This is Bash. So this is executed locally. It will be sent over the network. It has to be sent over the network. There are services where it is really possible that you directly on your developer network or your automation platform, you will really never look into Key Vault and never transfer the password. There are combinations of services where this is already possible, and this is definitely the goal where Microsoft is heading to. If you want to know more, Google for managed identity. There you will find a lot of information how this works. Typical example could be a web app executing or a web API executing a SQL Server database or Postgres database. You don't want to do anything. You don't want to write a single line of code. You just want to say, get the connection string from Key Vault and use it on this app service. And this is exactly what managed identity is all about. There's another question. Same question? Okay, very good. So now we have our container instance running. Let's see whether it runs. Here it is, the container instance. Let's copy this guy. It might take, yeah, here we are. This is Hello World. So now we have a complete round trip. We have created the image in Azure Container Registry, serverless. We have pushed it to Azure Container Registry. We have created a service principal, read-only, put it into Key Vault, and then we have created a container instance, a container running based on this image by using the service principal that has read-only permissions without ever touching a virtual machine. This is why I said this is serverless. Of course, if you want, yeah. You would have to specify a bunch of more, I think 2 more arguments here, and then you can specify a domain name. And if you think, is it possible to add an A record, a C name? Yes. All the obvious things that you are currently thinking of, they work. Yeah, you can store your certificates, and yeah, it works. For many of these serverless services, you also have integration with things like Let's Encrypt. So you get a nice little SSL certificate for free from Let's Encrypt that you can automatically renew and all these things. Yeah. Okay, nice. Last thing, we have 10 minutes left and we have 2 final demos, which are hopefully pretty impressive. The first one, it's all about integration now. The first one that I would like to do is I would like to show you how I can build larger, more complex microservice environments with ACR. So what I have done here, let me quickly start that. I have published a sample website. And this sample website, let me quickly, yeah, this is it. This is a sample website. This sample website is connecting to an Azure service which is called Event Grid. Event Grid is a platform for sending events in an event-driven microservice-oriented architecture. So you can have multiple senders, you have multiple recipients, and they can exchange events with a little bit of payload through this Event Grid. Again, it's serverless, so creating an event grid is essentially a question of a few seconds, and then you can send tens of thousands, if you pay a little bit more money, hundreds of thousands of events per second across this event grid. This is not messaging. This is not high-value business messaging, sending a business order or something via the network. This is eventing. High-frequency eventing as you know it from IoT scenarios, or where you can really send a lot of events per second. And the number of events that are available for free is pretty high, so it nearly costs nothing. So this website will just listen to an event, and we can now tell our Azure ACR to send events to this event grid whenever something interesting happens. Let's set up the event grid subscription. What this says is whenever something happens in our Azure Container Registry, please send it to this endpoint. And this endpoint is this small little web app that I have created here. So now we are done. Now these things are linked. And please, again, use your imagination. You can write any kind of web application that can receive this event. You can write it in Java, in Node.js, in PHP, in Ruby, in Python. It doesn't matter. It just has to be an HTTPS endpoint available on the internet. And now the Azure Container Registry will send an event to Event Grid, and Event Grid will notify your HTTP endpoint, kind of webhook. Okay? So if we now go up again, and where did we have our build? Yeah, let's now create the V2 of our image. Okay, let's do that. Nice. It will send it across the wire, and in a bunch of moments, we should see, it's already here. See that one? So Azure Container Registry already sent a message to our event grid. It sent an "Hey, are you there?" message. It was just a handshake. Okay, this is the so-called subscription validation. And if we wait for another few moments, then the upload should be done. Download complete. We are nearly done. Pushing. Now it gets interesting. Layer is pushed. Okay, and let's do it. And here we are. This is what I wanted to show you. This is now the web app running in the internet, receiving an event whenever a push happened. And you don't need to subscribe for pushing. You can subscribe for anything. You can say, give me a notification whenever a build happened, whenever a delete happened, whenever a push happened. And this could be the starting point for more complex DevOps scenarios. You could use this event with a workflow engine built in Azure, Logic Apps, I will show you that in a second, or write your own scripts that now automate the deployment of this image into your Kubernetes cluster or whatever you want to do with that. This is the starting point for a complex DevOps process, and the integration into Event Grid is thought for exactly that. okay? I didn't have to create any kind of Kafka, whatever infrastructure, it's just built in. Okay, and my last demo. Where were we? Here we were. My last demo is a webhook demo. Imagine the following. You don't want to be this kind of Microsoft Azure locked in thing. You like what you've seen with Event Grid. It's really nice, but Event Grid is only available in Azure. So if you do that, you can move your entire system out of Azure. Webhooks, just sending an HTTP request to any kind of environment, is something that is available everywhere, okay? So I wanted to show you as my last demo, the webhook integration. So instead of sending an event through Event Grid, I'm now sending a HTTP post whenever something happens to any kind of arbitrary HTTP endpoint, okay? This is what we are doing here. And what I have created for you is I have created a small workflow in Azure. Azure contains a workflow engine which is integrated with many software as a service solutions. I can show you that here. That's my workflow. And as you can see here, you have integration into Slack, for instance. You have, I don't know, Salesforce, you have SAP, you have all the things, you have Outlook, it's a workflow engine that you can use, and you can trigger these workflows using HTTP. And what I have set up for you is I have set up a workflow that just does a Slack post into our company Slack whenever I post something into this Azure Container Registry. So let's do that. Let's set up the webhook. Here is the webhook. Whenever somebody pushes something, I want to have it in my webhook target, and the webhook target is the address of my workflow in the cloud. So last time that we are going to build an image, v3, let's do that. And if everything works out nicely, we should see a Slack notification in a bunch of seconds. So webhooks are the second mechanism to integrate your Azure ACR and your Azure ACR builds with downstream systems and more complex DevOps infrastructures. Event Grid is the other possibility. What I can't show you because of lack of time is the integration with GitHub, and I can't show you the integration with automatically building images based on operating system refreshes, but you can take a look in my slides and in my sample scripts. It's only 2 lines of code, and you can try it at home if you want. Okay, so let's wait for the last time for these few seconds. Done. And if I take a look in my demo, it's already lighting up here, and you see here we are. It's 4:13 p.m. and that's exactly our time here. This Slack message, hello World Web v3, this is exactly the message that was triggered by a webhook of Azure ACR into our Logic app. Logic app talked to the Slack API, and the Slack API sent something into my channel. That is the idea here, okay? Nice. Good. Summary. Azure loves Docker. We can really say that. So we have Azure ACR, we have Kubernetes managed, we have ACI, we have app services, and so on. Docker is a first-class citizen in the Azure platform for Windows and for Linux. And I hope you have seen that for the ACR. We could do exactly the same thing with the other container platforms. Microsoft is really strong when it comes to PaaS and serverless. The focus of Microsoft in terms of containers is PaaS and serverless. It's not so much about infrastructure as a service and VMs, okay? Here you have a list of services which are relevant in Azure for containers. And my last thing is, have fun with Docker on Azure. Give it a try. I hope the last 60 minutes were interesting. You have seen something new. You have learned something about Azure, about containers, and so on. You have gotten my slides. You have gotten my samples. I hope you liked the session. I would like to say thank you for coming to this session. And if you have any questions, feel free to come to the front and talk to me. I have to rush a little bit, so please don't be angry with me if I pack my stuff while talking to you. I have to catch a train because I have to run home. It's my 3rd day on trip and doing various conferences, so I'm really looking forward to get home again. So thank you very much, and enjoy the rest of the DevOpsCon.